Hey Global Impact students, this is Mr. Ellinger. Today's lesson we're going to discuss properties of real numbers. We have one learning target for this lesson, and that is to identify and use properties of real numbers. Two essential understandings for you for this lesson. The first one is that relationships that are always true for real numbers are called properties, which are rules used to rewrite and compare expressions. Important properties include the commutative, associative, and identity properties, the zero property of multiplication, and the multiplication property of -1. Background for this lesson: the process for solving any equation, which we will do very soon, in one variable is to create a series of equivalent equations until the variable is isolated and has a coefficient of 1. Equivalent equations and inequalities are created by applying the properties of real numbers introduced in this lesson, as well as properties that will be introduced in later lessons. You should know the formal names of the properties so that they become familiar with the vocabulary used when discussing algebra and justifying operations. A strong knowledge and understanding of properties will help you in later chapters and in higher level mathematics as you begin to prove theorems. You will learn to use logic and reasoning, which will help in writing algebraic and geometric proofs. Okay, so two algebraic expressions are what we call equivalent expressions if they have the same value for all values of the variables. In this lesson, we are going to look at properties of equality. These properties are the basis for many of the things that we do in algebra. So here we have an equation, and basically an equation is just two expressions connected with an equal sign. So we have an expression on the left, we have an expression on the right, and we have an equal sign in between them. The truthfulness of this equation depends on the value of x, and we'll get into that more later. But for now, we just need to understand that an equation is just two expressions set equal to each other. So here we have some properties of real numbers. So it says let a, b, and c be any real numbers, meaning they can be anything, any real number. So we have what's called the commutative properties of addition and multiplication. We have the associative properties of addition and multiplication. We have identity properties of addition and multiplication. We have a zero property of multiplication, and we have a multiplication property of -1. So let's focus on the commutative property first. Basically what the commutative property says, you can add two things in whatever order you like. So we have the expression there, a plus b equals b plus a. Switching the order of addition is not going to change the value of the expression. Multiplication works the same way. A times b equals b times a. You can multiply things in any order that you like. Again, the associative property of addition and multiplication says changing the grouping of the addends does not change the sum. Changing the grouping of the factors does not change the product. What this means is if you're going to group items together for addition or multiplication, you can group whatever items together that you'd like. So the addition example is the quantity a plus b plus c equals a plus the quantity b plus c. And it works the same way with multiplication. And you can see a few examples there. If you go ahead and calculate the left side of those equations, calculate the right side of those equations, you're going to get the same values on the left and the right. So let's talk about simplifying expressions. We know what simplify means. Simplify means do what you can. Do the math. Multiply, add, subtract, divide, exponents, roots. Okay, anything that we can do, we need to go ahead and do it. So our first expression here says we're going to take 2.1 quantity 4.5x. Remember, 2.1 in front of this parenthesis implies multiplication. So it's 2.1 times the quantity 4.5x. 4.5x means 4.5 times x. So really what we have here are three things that are multiplied together. 2.1 times 4.5 times x. Again, all multiplication in there. By the associative property of multiplication, we can regroup this 2.1 times 4.5, since those are both numbers, and then we'll multiply that product by x. 2.1 times 4.5 is 9.45, and then we have times x, so we'll just put x. So this product, by the associative property of multiplication, is 9.45x. Here we have another example, 6 plus the quantity 4h plus 3. Well, in that expression we have two terms, two items that are alike, 6 and 3. So we want to go ahead and add those together. We can't add 6 or 3 to 4h because they're not what are called like terms. And we'll get into like terms a little bit later. So we want to add 6 and 3 together. So let's group them together. 6 plus 3 plus 4h. So we just reordered the items in the expression. 6 plus 3 is 9. So we have 9 plus 4h. Third expression here, we've got a fraction. Okay, so what we're going to do with this fraction is we're going to use the associative property of multiplication. Okay, anytime we have a fraction like this that has multiple items in the numerator, multiple items in the denominator, no addition or subtraction, just all multiplication, we know that the numerator is 8 times m. We know that the denominator is 12 times m times n. The next thing that we need to do is we can separate this big fraction into separate fractions. So what we'll do is we'll take the number part in the numerator and denominator and separate that into its own fraction, 8 over 12. We'll take the like variables, m over m, in their own fraction, and then we'll write 1 over n for our third fraction. The reason that we have 1 is because in the numerator, in the original problem, we had 8m. We know that that's 8 times m. We've already used the 8 times the m in our first two fractions as we're separating this. We have to have a placeholder here. It's not a 0, it's a 1, because remember, if we were to multiply this back together, we would multiply 8 times m times whatever's here. And since the product is 8m, we have to multiply 8m times 1 for that to remain 8m. The next step after this is to go fraction by fraction and reduce or simplify what we can. 8 over 12 reduces down to 2 over 3. M over m is a little bit strange, maybe. It actually has a value of 1. The question is why? Well, any fraction where the numerator and the denominator are identical, the same, whether you have two numbers, a number in the numerator and the number in the denominator, or whether you have variables in the numerator and the denominator. If they're the same, then that fraction is going to have a value of 1. Our last fraction, 1 over n, we can't do anything with that. We can't simplify it at all. So we've simplified everything that we can. The last thing to do is to go ahead and put this all back together in a big fraction, just as our original problem was. So 2 times 1, now 1, we could rewrite the 1 as 1 over 1, right? 1 is the same as 1 over 1. And that might help us when we have to go back to multiply this back together. 2 times 1 is 2. Across the top in the numerators, multiply the denominators. 3 times 1 is 3, times n is 3n. So this original expression, 8m over 12mn, reduces down or simplifies down to 2 over 3n. In the last examples, we were using reasoning and properties to show that two expressions are equivalent, leading us to an end result of a simplified expression. This is an example of deductive reasoning. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. To show that a statement is not true, find an example for which it is not true or false. An example showing that a statement is false is called a counterexample. You need only one counterexample to prove that a statement is false. However, for a statement to be true, it must be true for all possibilities. So here's an example. We want to know in parts A and B whether the statements are true or false. If it is false, we need to find a counterexample. If it is true, we're going to use properties of real numbers to show the expressions are equivalent, meaning our commutative associative properties. So part A says, for the real numbers j and k, j times k is equivalent to k plus 0, that quantity, times j. True or false? Well, that's a true statement. J times k equals k plus 0 times j. Well, what we're going to do is we're going to use identity property of addition. That property tells us that j times k is the same as k times j, right? And we know that j times k equals j times k. We can switch the j and the k by the commutative property of multiplication. So we do have equivalent expressions. Part B, for all real numbers m and n, m times the quantity n plus 1 equals mn plus 1. Is that true or false? Well, again, we've got to find a counterexample. Let's try this for m equals 4 and n equals 3. If m is 4 and n is 3, we evaluate this expression, we'll have 4 times the quantity 3 plus 1. Again, I'll put my values I'm substituting in parentheses, equals, put 4 in for m, 3 in for n, plus 1. Order of operations, I'm going to do 3 plus 1 first, so I'll have a 4 times this parentheses. I get a value of 4 in that parentheses. Over here, I do 4 times 3, which is 12. Alright, so I'm left with 4 times 4 equals 12 plus 1. Over here, 4 times 4 is 16. 12 plus 1 is 13. So this, part B, is a false statement. And one counterexample would be if m is 4 and n is 3. I'm sure there are many others. So a follow-up question to this is the statement in part B false for every pair of real numbers m and n? Meaning, is there a pair of numbers m and n where maybe that is a true statement? And if you take a look at it for a minute, maybe you'll come up with a pair of numbers where it is actually true. If you let m equal 1 and n equal 1 as well, substitute those values into our expression, we will add this first. 1 plus 1 is 2. So on the left side we'll have 1 times 2 equals, here we have 1 times 1 is 1 plus 1. 1 times 2 is 2. 1 plus 1 is 2. So we get a true statement when m is 1 and when n is also 1. Okay, so there may be pairs of numbers where we do get a true statement here, but if we have a counterexample, with just one counterexample, then the original statement is going to be false. Have a good day.